In this video, we will have a look at the while loop in Matlab. So we already had example of for loop, which is doing a number of evaluations when we know the desired number of steps. But sometimes we don't know how many steps we need to take to achieve a goal. Now, if I go back to the example of my kids running around the table, if I want to play a while loop with them, I will say, keep running around the table until mom tells you not. So now they don't know in advance will they have to make just one round, 5, or maybe 100, since they don't know the moment when the stopping condition is coming. So that's what while loop is for. And the construct is similar by look to for loop. So we have while expression and set of commands. But now the commands inside the loop will be repeated as long as the expression returns true value. So you could think of this while in other way as long as expression. So as long as. And now it will run when this is true, when this is a scalar, so like a single value. In case this is an array, then all the elements in that array would have to be true for the commands to be evaluated. So let's have a look at an example. We would like to check how many times we need to divide x, starting with the starting value 2 by 3 to get a result that is smaller than some small number. So we want to keep dividing until we get something smaller than 0.005. So if we write a code, clear all to clear variables, then we define our x as 2, we define the divider, then we have the counter, because we want to keep counting how many times, and then we have the threshold, which we want to achieve. So let's write it. Clear all. So I have my x equal 2, I divide by 3, my count starts from 0, and the threshold was 0.005. So now I write my loop, and I say, while, so I want to keep dividing as long as x is still bigger than this. So if this is true, and it is true at the beginning because 2 is bigger than that, we will be dividing. And it should only stop when x, once divided enough many times, will be smaller than 0.005. So I divide my x, and I count the steps that I have made one more division. Okay, let's run it. And now what happens is that it keeps running and running and running, and it just doesn't want to stop. So first of all, if you end up in an endless loop, Control C is the way to stop it. So you have to stand in the command window and press Control C. So whatever long calculation or endless calculation you have, it will always stop it. But now what's the reason? The reason is that I was dividing x by d, so 2 by 3, but I was all the time dividing 2 by 3 and not updating the value of my x to something new. So in here, I should have done this, so that after a particular step, my new value of x is the old value of x divided by 3 in this case. And the same when I want to count my number of steps that is needed, I should do it like this, because first I started from 0, I had no steps done. When I enter the loop, my steps increase by 1, so this value goes into n, so it keeps increasing. Now let's run it. So we have n 6 steps. So first, after first division, we had this value. So this was the first step. After second step, we had this value. Third step, this value. Fourth, fifth, and sixth. So you see, sixth one, it is less than 0.005. I was mentioning about hiding the outputs. So loops are the case where you should make use of that. Normally, when you use loops, you don't want to see all those intermediate numbers. You want to see them if maybe you're getting some silly result or you have an endless loop and you would like to see, follow the steps, what is happening. But once you know the loop is working correctly, you should hide those and you should only pick the final result. So here I would say fprintf the required, or maybe like this, we need to divide there will be x here, x by 3 times in order to achieve a number below, and there will be our threshold here. And now I have to provide one by one what we had in here. So we need to divide x by the n times in order to achieve the threshold. Okay, let's run it. And here's our answer. I can reduce those precisions here. At least this we know it's an integer. And also here to achieve number below. And we can reduce the precision here as well. Let's say to just 4. So let's run it again. And now we have our answer. We need to, oh yeah, it's almost right. We need to divide this. Of course, we don't need to divide this. We need to divide the initial x. So I would need to maybe call this capital X, maybe, and this small x comes from capital X. So I actually use this capital X here as the starting point. Yeah, so now it shows us, oops, I have accidentally put it on the wrong side, 0.0 was here. Yes, so we need to divide 2 by 3 6 times in order to achieve a number below 0.005. And this is the fix on the slide. So remember, if you need a loop where you know how many steps should be evaluated, then use for, and otherwise while is the one to do. But you have to remember that that condition which makes it run needs to have some parameters that are modified inside your loop, so that something is happening in here that always keeps changing that condition, so that at some point it will stop and you will not have an endless loop.